Start recording. Here we go. Ex6DFG. What are you doing? To reduce your time in work, you probably can just focus on 6G if you're confident to do the graphs with all transformations. If you wanted some scaffolding, then 6D will then do a couple of dilations, and then 6F, there's a bit of translations. And then if you go into 6G, it does the whole shebang. Okay, so the idea is that if you can do the entire transformation, for example, this is the question I'm going to do example for you later. Okay, something like this one. Like that, where you have a dilation. This is actually missing a dilation from the y-axis as well, but it does have. Thanks, team. You can talk about your SAC later on. You got your translation, so vertical and horizontal. Arguably, once you have a vertical translation, it makes it a bit harder because it changes your axis intercepts. That means you have to use what you learned previous lessons to solve for x-axis intercepts, solve for endpoints, and then put in your graph and figure out how many cycles you get. So this one would be tricky. That's from exercise 6G, and that's ideally that's where you want to be able to do. To start off, let's look at some basic properties of a sine and a cosine. Last year, you learned that a sine graph, one cycle, usually we say from 0 to 2 pi, it looks like this. Okay, that's from 0 to 2 pi. But we know that a sine graph oscillates infinitely, so infinitely negative and infinitely positive. Hence, they have to give you some sort of domain to restrict it. So here we go. This is your 0 to 2 pi, your basic graph for sine. And I use that first cycle to help me sketch for 6G, just looking at the patterns that you can see there. Okay, what I can see is it starts off at the middle. Okay, so the middle ground, then by 90 degrees, it then reaches maximum. Then another 90 degrees, which reaches pi. You get to middle ground again, and then another 90 degrees, which makes it 270 degrees now. You're back to, well, you're at the very bottom. And then another 90 degrees, now you reach at 360 degrees, and you're back to the middle. So there's a pattern there. And later I'm going to show you a technique that for those who find it hard to figure out how many cycles or when do you go to the top, when do you go to the bottom, especially when they restrict the domains from negative pi to pi, and you have a dilation as well. How do you sort of visualize it? I've got a technique that it takes a while to do, but your graph will look really nice, and you'll also be able to tell where it turns and where your dot points, endpoints should end up. And it's called the quarter cycle because there's a pattern there. That every quarter, so 2 pi is the entire distance, quarter of that, which is 2 pi divided by 4, you get pi on 2. So every quarter cycle, I'm just going to do a little arrow here and call it QC. So every quarter cycle, it actually moves from the middle to the top, top to the middle, middle to the bottom, bottom to the middle, middle to the top. And that pattern just oscillates every quarter cycle. So once you know the period, if you know what the quarter cycle is, you can predict roughly where your endpoint should be based on the domain. I'll show it to you later so you can see how I would sketch and how it keeps it nice. And when you set up your axes, the scale makes it easier too. Okay? But here are a couple of things. We still have the same things to note from transformations. A represents what? Can I please have? Let's go with Sam. What's A? What kind of transformation is that?
A is a dilation.
It is a dilation factor. A, that's correct. Dilation factor A from which axes though? The x-axis, because it affects your y values. Very good. So that is a vertical stretch. So think of A, that's why it's called your amplitude, because it stretches your graph vertically. Okay, so that's your amplitude, okay, which is also known aka amplitude. But really it's just the vertical stretch. Then we have C, which is the easiest one. What does C represent? Can I please have Xavier? What's C? Well, depending on which graph it is, yeah. Usually for polynomials it is, but in this case, just in terms of transformations. I don't want to know the intercept, I just want to know transformations. Very good. So this translates up or down. Next one. What does x minus b do to the graph? Can I please have Noah? Very good. This is horizontal translation. And then finally, n, which often you learnt last year, this was known as your period. But what is it truly? It is and represents what, Rango?
It's something pi on 2.
Yes, you're right. Well, the period is equal to 2 pi on n. But what I'm curious is, why is it on n? Because what you learned from chapter 3, transformations, explains why it's on n. So what's the n in terms of transformations? Oh, Rango again.
It's like the opposite of the y one. So when you put it into the x, the n's on the bottom, but it sort of represents the dilation from the y-axis.
Very good. It is actually the dilation of factor. Now, unlike the one that I got Samuel to do, that was factor of a. Okay, so we know that when it's affecting the y values, it's just a factor of a. But when you're affecting the x values, we know it's going to be the reciprocal. So if it's n, so let's say 2, then we know it's going to be dilation factor half from the y-axis. And it just basically means you're compressing the graph closer, which is interesting because that is why, if we know a period is 2 pi, by putting n there, you're doing a dilation of factor 1 on n. That is why you take one cycle of 2 pi, that's your typical cycle, and you're shrinking it by 1 on n. That's where it comes from. Okay, so it's your dilation of factor 1 on n from your y-axis. Okay, it's a horizontal stretch. So the other one was a vertical stretch. That's why it affects your amplitude. This is a horizontal stretch, which is why it affects your period. Yeah, so if you pull it out further, then it gets wider. If you compress it, which is usually, if it's 2, you're compressing it. That's why you get multiple cycles within one period. Okay? So that's where chapter 3 lends itself for you to understand what each of these letters do. And like I said, 6D, 6F, 6G will increase in difficulty on how you would sketch the graph. Knowing the first cycle will help you to visualize. Okay? Now, cosine graph, all that applies the same. The only difference between the two, if you think about the unit circle, we know that cosine, so cosine, I'm just going to draw a circle. When it starts off at 0 degrees, what is cos of 0? What's cosine of 0 again? 1. That's very good. If you look at the picture, you can see cosine represents the x-axis values. So at 0 degrees, this point, that's 1, 0. So x is equal to 1. So cos must be 1. That's why at 0, your value is at 1. Whereas sine, if you look at that, sine is meant to be 0. Okay, because the y values are 0 at that point before. So hence, the only difference between the two is you're starting off at the maximum point. And then as you're going through the unit circle, by 90 degrees, your x value now is reaching 0, which is why after a quarter cycle, it goes back to 0. So top, middle, bottom, middle, top. And that is your typical cosine graph. And just remembering that, that will help you sketch. And I'm going to show you how to sketch the more complicated ones. Okay, so from 6G, and tomorrow you get to practice. I'll have a worksheet for you where I'll put all the transformations, I'll put all the negatives, I'll put all the left, right, up, down, and let's see if you can visualize what it looks like using my technique. Okay, obviously if you've learnt other techniques, feel free to use them. I'm just giving you an extra so that you feel confident with sketching. Yeah? All right, team, so what is the period? We already said before, the period is equal to 2 pi on n. The range, what is the range for your cosine and sine graphs? What's the range?
1, -1 to 1.
It's -1 to 1, okay? But the 1 usually depends on A, okay? Because if A is 1, then the amplitude is 1. But that's why I wrote here as a general rule, your amplitude is affected by your dilation, but also your vertical translation. So, for example, if I gave you the question 2 cos of x plus 1. Now, we have to visualize this. Normally, like you said, 1 to -1, that's your typical cos graph. But since I now have an amplitude of 2, what should the max value be and what should the minimum value be? Not -1?
3 and 1.
3 and 1. Okay, very good. So before we get to that, that 2 changes it so that it is now vertical stretch. The amplitude is now times up by 2. So that means I'm going to times this by 2 as well. So now you have a graph that's meant to look like this. Oh, sorry. So it should be from -2 to 2, but then there's a +1. So the +1 shifts the graph up. If it shifts it up, that -2 now ends up at -1, and that 2 ends up at 3, which is why Noah said -1 to 3. This is your new range. So how did I work that out? I needed my A, and I needed the C. So A is where I start off with -2 and 2. The C, I added 1 to it. So that means your range is, and I wrote a general rule here, you've got C minus your A, and then C plus your A. Okay, so whatever your A is. If A is 2, just like before, so 1 minus 2 gave you that -1 that Noah was talking about. C plus A, that would have been 1 plus 2, and that's how Noah said -1 to 3 is your range. Okay, so that's just a formula to help you if you didn't understand transformations, but ideally I'd want you to learn how to do transformations rather than just memorize those rules. Okay? All right, let's put it all to practice now. So this is the theory. That's your graph and that's your theory. Let's do this one. So this one's a bit big, but let's start off by identifying. So the first skill in terms of fluency skills, understanding the graph, last year you needed to be able to identify amplitude, period, the range, right? You start off with that. Those are the basic skills first. Now in year 12, we're going to try just sketching it. Yeah, but let's start off. What's my amplitude in this question here? Can I please have, let's go with Albert. What's my amplitude? 3. A is equal to 3. Again, that's your dilation, which affects your amplitude. Very good. What is my period equal to? 2 pi on n. What is that equal to? Let's go with Jaden. Yes, you're correct, actually. 2 pi on 2, that is equal to pi. Next one, range. You can use the formula I just gave you, or you can use a bit of transformations here. What is my range equal to? Let's go with Neil. Sorry, I didn't hear that. Very good. -3 to 3. In this case, I did not have any vertical translation. There is a vertical stretch, and hence instead of -1 to 1, it is now -3 to 3. Very good. So what I should be picturing is this. If I've got a range from -3 to 3, that means on this graph, which I actually got the axes for you, it's already at minimum maximum. That's your max, that's your min. So where's the middle? 0. Okay, find the average of the max and minimum. So if you know the max, you know the minimum, find the average of those two, that tells you where the middle is. So the middle is at 0. So remember the technique I taught you, that as long as you know what the quarter cycle is, you can predict the graph because it goes from top, middle, bottom, middle, top, and it follows that cycle, right? Here's a cosine graph. Let's visualize it. A normal cosine graph looks like this. 2 pi and -1 there, right? I said that once you know your period, you can work out the quarter cycle so that you know max, middle, bottom, middle, max. So let's work out the quarter cycles. You told me the period is equal to pi. Then what's the quarter cycle equal to? What's a quarter of pi? Pi and 4. So that means for every pi on 4, I should be able to move from top to middle to bottom to middle to top. That's the logic. Where's the starting point? So your starting point is here. We know that from a basic graph that without any translations, it starts off at 0, 1 at the maximum. Now, reading the transformations of this graph, I don't have any vertical translations. So this doesn't go up or down. It's still at 3. So looking at the graph, I know the starting point must still be here. That's where my starting point should be. Doesn't move up or down, but it does move left or right. Where does it move? Rango. Beautiful. This is right by pi and 4. So this is what I do. This is how I do it and how I teach my students. If you struggle with sketching sine and cosine graphs, you know that it would have started off at 0, 3, but because it moves to the right by pi on 4, I take that point and I move it across. So it must be, this is my starting point at pi on 4, 3, because there's no vertical translations. That's the first point I've got. Now that's my first point. To find the next point, it's the quarter cycle. From here, pi on 4, if I add on a quarter cycle, that should bring me to the middle, which is at 0. So let's try it. Quarter cycle is pi on 4, and I have a starting point of pi on 4 as well. If I add a quarter cycle, which is adding on pi on 4, notice that denominators are already the same. All I'm really doing is I'm just saying the scale should be in pi on 4s. Since I'm just adding on pi on 4, that's adding on an extra 1. So as long as the scale is in pi on 4, so this is 1 pi on 4, this is 2 pi on 4, this is 3 pi on 4, this is 4 pi on 4, this is 5 pi on 4, and you can write this all the way up. You can go all the way as much as you need. However, the domain was 0 to 2 pi. So that means you can only go as far as 8 pi on 4. So that means 5 pi, 6 pi on 4, 7 pi on 4, and then finally 8 pi on 4. Now, here's the logic. If I know that I'm adding 1 quarter cycle to get to the middle, then that means my next point has to be right here. That must be my next point. Because as pi on 4, add on a quarter period. You told me add on pi on 4, so 1 pi on 4 plus another 1 pi on 4 is 2 pi on 4. And that makes it really easy to figure out now, because every extra 1, you're going top, middle, and middle, top. So if I follow that pattern, this is what it looks like. 3 pi on 4 should go here, because that's an extra pi on 4. Back to the middle, back to the top, back to the middle, back to the top, bottom, back to the middle. And so if I go backwards, that was going forwards. If you go backwards, it's then subtract pi on 4. And conveniently, it actually lands on 0. So the the domain was 0 to 2 pi. I can already see the graph looking like that. Whoa, what happened there? Something like that. And as long as you get middle, max, middle, min, and you've got your scale, and your scale is just dependent on this part. When you do pi on 4, so the starting point, plus the quarter period, as long as you match the denominators, that's your scale. So for example, if it was pi on 4, but your quarter period was pi on 3, then you should change it to the lowest common denominator. It's 12. So this would then be 12, and then this would have been 12 as well, but that's 4. So then you know every 4 movement across, and you change your scales to 12s. If you change your scales to 12s, it's always going to match. And you'll be able to get top, middle, bottom, just like the way I did, and it's easier to sketch.
How safe would it be to write that as 3 sine 2x?
Yes.
Is that a good idea to do that?
I think for some questions in methods, they do, but they don't expect, because I think there's some, especially Spesh, I think Spesh, they do some conversions between it, and sometimes your textbooks also do some conversions as well because of the complementary property between a sine and a cosine. They're sort of difference by 90 degrees, which is quarter cycle. That's why you can convert. But I don't think they normally expect you to convert in the exam. Yeah. All right, team. So that's the technique, and that's pretty much 6F. Okay, so you can skip 6D if you felt comfortable with what I just taught you there. You can skip 6D and just work on 6F just to get no vertical translations. The only difference is if I added a vertical translation, you wouldn't have got these x-axis intercepts easily. It means you have to solve for it. Okay, so that's why it takes longer to do. So 6G has vertical translations, 6F doesn't. And you're just working on some dilations, means a couple of cycles in between. But if you stick to what I'm showing you, you should be able to do even 6G. Okay, so let's have a look. Let's do one. Let's do one. So turn over to the next page, and this is our last example for today. Let's do one with a vertical translation now. So I'm going to show you how I would do it. Same technique, and you would still be able to sketch it. So here we go. We did a cosine before. This time, I'm doing a sine graph. Let's read the transformation. So hopefully now you know this is your amplitude. So amplitude is √2. You're going down 1. And there is a dilation factor. Now, if you can't read whether you're moving left or right, you can factorize the 2. So if you factorize the 2, it becomes obvious that you're moving left pi on 2, dilation factor half from y. You see how I'm using chapter 3 transformations to read it? So start off with the period, because the period will tell you the quarter cycle. So here we go. Period is 2 pi divided by n. Since n is 2, 2 pi on 2 gives you 1 pi. So that means a quarter cycle must still be pi and 4, just like before. All right, so quarter cycle is pi and 4. Great. What's the first step in sketching this graph and how I've been teaching you? I said, start off with the starting point. So where's my starting point? The starting point for a sine graph. Picture a sine graph. We know that it starts off at 0, goes up, goes down, goes bottom, goes top. So my very first starting point is right at 0, 0 normally. We said down 1, and then we also know left by pi and 2. So that means I'm moving this by down 1, and then left pi and 2. Okay? Problem is that, remember, you're not just down 1, you've got an amplitude of √2. So that means it's positive √2, so -1 plus √2, whatever that value is, and then I'm moving to the left by negative pi and 2. Now, out of curiosity, what's this value roughly? Is it positive or is it negative? So figure out √2. What's √2 roughly? Don't have to be exact, you can just guess it. Roughly, yeah. Because root of 1 is 1, and root of 4 is 2, so that means this must be closer to 1. But I just know the thing is it must be bigger than 1, right? So √2 must be bigger than 1. It's greater than 1. So if I took a -1 plus something that's greater than 1, am I going to get a positive number or a negative number? Positive, right? So that means my lowest, my value, so remember √2 at the top, I've gone down by 1, so I'm -1. My maximum value is still going to be in the positive region. And then my minimum value, remember, it was negative √2, and then you still got a -1. Negative √2 minus 1 gets it more negative. So I still have a positive value at the top, and I still have a negative value on the bottom. Does that make sense of what I'm sort of picturing? Yeah, so look about the range. All right. Now that we know that, so where's the starting point? The starting point was, instead of it being at 0, it's gone down by 1, okay? And then it's gone to the left by pi on 2. So here we go. Here's my normal sine graph. Normal sine graph is usually like this, like that. The amplitude only changed the height, okay? But I'm taking this starting point. That's the starting point that's most key. I go down 1, left by pi and 2. So here we go. Down 1, left by pi and 2. So here's my starting point. Remember your maximum, we said it was just a bit over, so it was -1 plus √2, and √2 is just a bit bigger than 1, so if you add them together, they should be just somewhere in this region here. So you can just probably say your maximum is √2 minus 1, somewhere there. You can do a bit of a guess. Next one, √2, √2, -√2 minus 1, so that should give you about -2 point something. So you can guess it about somewhere here. So negative root 2 minus 1. So this gives you now a picture. Maximum value, minimum value, middle. Okay, so you just needed to max, middle, min. See how I got that? So this tells you the maximum range, minimum range, middle line. That's what I was trying to do. Now you can do the quarter cycle and just fill in the dots. All right, so here we go. Our starting point, remember this is at negative pi on 2 down by 1. Here we go. Let's work out our quarter cycles. So we start off at negative pi on 2. And if you're adding on a quarter cycle, so pi on 4, what's the lowest common multiple here? Negative pi on 2 plus pi on 4. What's the lowest common multiple? 4. So all I have to do is I'll change this negative half to negative 2 pi on 4 plus pi on 4. So that means my scale, I should be working in quarters. That's why I gave you in quarter cycles here. Yeah, so that's pi on 4. This is 2 pi on 4. This is negative 3 pi on 4. This is negative 4 pi on 4. That's why I was working in pi on 4s, because it's easy to figure out. You're starting at negative 2 pi on 4, and you're adding 1 every time. So now, here's my starting point at negative 2 pi on 4. Every quarter cycle is 1 pi on 4 across. So that means this is what it looks like. Sine graph goes middle, top, middle. So top, middle, bottom, middle, top, middle, bottom, and I can just keep following that pattern. Can you see what I'm doing? It's just every quarter cycle, every pi and 4, because the scale's done correctly now. It's every quarter cycle top, next quarter cycle middle, next quarter cycle bottom, next quarter cycle middle, next quarter cycle max, next quarter cycle middle. And you just keep going until you get up to your domain that they specify. And you can do the same backwards. If you go backwards, it would have been next quarter cycle down, next quarter cycle up, next quarter cycle max. So visually already, I've kind of got my picture. If I just join the dots at the moment, this is what my graph, whoops, it keeps doing that, roughly looks like. You see what I'm doing? And that means I just need to work out the endpoints now. Endpoints, and because we had a vertical translation, we don't know what these x-axis intercepts are. That's why it takes longer. Okay, but can you see how I get the shape? Getting the shape with the quarter cycles makes it easy for you to predict. Does it go up? Does it go down? Where does it get cut off between negative pi to pi? So I'm just looking at that and I've just set it up so that it works out nicely. Cool, so that's just to help you when you start doing exercise 6G, how to get the shape. What am I missing to get the proper marks? I'm missing the endpoints. So you need to figure out at x equals to pi, what does y equal to? At x equals to negative pi, what does y equal to? And then your final one is x-intercepts. You need to solve when y equals 0, find x. Now this is exercise 6D and 6E, I think. I'll say 6E. So if you haven't practiced 6E, then the sketching part will be tougher. Okay, so I gave a side of the page over here, finding x-intercepts, so you're practicing 6E to get your x-intercepts, but in terms of the shape, that's what I mean by quarter cycles. Okay, so the quarter cycle should help you find maximum and minimum. But this type of question, for a sort of person who's practicing, it should take you about 15, 20 minutes, usually, for the first time, because it depends on how fast you can find axis intercepts, how good are you with search to find your endpoints, and then how good were you at doing what I just described, doing quarter cycles. Yeah, so the faster you can do the quarter cycles and visualize it, and it's quicker. I'm explaining it, so it's already taken 29 minutes in total to do those two. Yeah, so on average, I would say 15 to 20 minutes for the first time. As you do it better, your 6E improves, you find the axis intercepts quicker, and the shape will be easier just following the quarter cycles. Okay, so there's a lot of ways to find the shape. Your tutors might have taught you differently. I find the quarter cycle is the easiest way to teach students how to find max, min, and middle. And then you know, depending on, no matter what the domain is, you'll always figure out whether you're a bit above or a bit below. Cool? All right, I'm going to stop there. If you need help with 6E, I'll come around to work with solving axis intercepts, but 6DFG is about getting the shape. Okay, so getting the shape for sine and cosine. All right, if you want to practice more, look at 6G. Last question. They have translations and vertical translation horizontal. That really practices your skill to be able to get that graph. It's about 15, 20 minutes for the first time. Okay, here we go.